All right, this video is going to go over polar coordinates, how to plot them, how to convert them to rectangular, how to convert it back, everything you need to know about that. So let's go ahead and get started. The first thing I'll say is you need to know the difference. So rectangular coordinates are what you're used to seeing. They just have an X and a Y. Those are easy. But now we're going to be dealing with polar. And polar, they do a radius first and an angle. Now your angles are going to be just like you learned it. They'll be rotating positively this way, positive theta. And if it's a negative angle, you're going to rotate this way. All right, so just keep that in mind. Now, let's look at some examples. Look at like number 1, for example. When I do these, I like to draw the amount of, or the radius first. So this first number basically tells you the radius of these coordinates. And so what I mean by that is you need to start by drawing that amount of circles. And if you think about these circles, we're basically saying each one of these has like a length of 1. So like there's 1, there's 1, there's 1. So when you put them all together, it's a radius of 3. But anyways, draw the amount of circles, so 3. Do your angle rotation, pi over 2. So that would be this much, right? And where you end up, which would be here, make it be like a little arrow pointing to the name of the coordinate, done. That's all there is to it. So like, look at the next one, 2 comma 5 pi over 4. I would be drawing 2 circles. I would be rotating 5 pi over 4, which would be like that amount. I would draw an arrow and I would call it B. That's all you have to do. Now, the way that they can make these harder is, for example, like number 3, they'll make your radius negative. So what you need to do is still draw that amount of circles. So 1 circle, here it is. And then plot it as if it was normal. So 11 pi over 6 would be all the way over here, basically in quadrant 4. It would be like this. So if everything was positive, that is where it would end up. However, when it's a negative r, you have to do what I call a pivot. It's like a 180-degree pivot opposite from that location. So green is actually the location of point C, not red. Red's just kind of there as a reference for me of where I need to pivot off of. So like, let's look at D. All right, I would be drawing 4 circles. 1, 2, 3, and 4. All right. Now I would do my regular 2 pi over 3 rotation, which is going to put me in quadrant 2 here. So it'd be like here. So if it was a positive r, that's where it would be. However, it's a negative 4 for that r. So you have to pivot off of this spot 180 degrees. And that's where you actually end up for that point. Okay, let's look at one more. What if they give you a negative angle or a negative angle and a negative r? Like, okay, we'll do 2 more. We're going to do 7 first, and we'll do 6. Look at number 7. You'd be drawing 4 circles. You would be rotating. Oh, I thought it was a negative r. Oh, well, we'll still finish it. You'd be rotating pi amount. It's okay that it's a quadrantal. And then you would have to pivot 180. So this is where point Y would actually be. All right, now what if they gave you a negative angle, like number 6? All right, you are only drawing 1 circle. Now, You do the angle first still. So negative 4 pi over 3. Just be careful you don't rotate this way. It's a negative angle, meaning you are rotating this way. So you do negative 4 pi over 3, which is like here. So it puts you here. All right. And then you just pivot off of that since the radius is a negative. So it would just pivot off of this and it would be somewhere like here-ish. That's where X would be, not the red. So you still draw the same circles. You then do the angle rotation and then you look and see if your R is negative, you need to pivot 180 degrees. That's all there is to plotting polar coordinates. Now, before we start converting, I want to show you a couple more things that you need to be thinking about. Look at this page. Sometimes they'll give you like this polar coordinate and they'll want it written a different way. So here's what I mean by this. If I approach problem number 31, I would go ahead and plot the original. So it's 3 circles. It's a 4 pi over 3 angle with a pivot because that's negative 3r. So you would do 4 pi over 3 with a pivot. So it would look like this. Here's 4 pi over 3. Here's the pivot. Now, as soon as we'll call this point A. As soon as I find out where A is, me personally, I like to write the reference angle. So this one, it's pi over 3. Because we did 4 pi over 3 with the pivot. Basically, whatever the angle is, you can pretty much see the reference angle right away, just like usual. All right, so I'm here at green at A. Now, what they're going to do is they're going to tell me they want a coordinate for that spot with these specifications. So this means R greater than 0. So that means a positive R. And then this angle, they're saying between 0 and 2 pi. So that is a positive theta. So they want this spot, A, with a positive R and positive theta. Well, the R, the radius, is just 3. There's 3 circles there. Now the theta, I use my reference angle, pi over 3. And I think what quadrant am I in, etc. So this one would just be pi over 3. Now, the more of these that I do, the more sense it's going to make. So let's look at this next one. I am on 32. Go ahead and plot what they give you. So there's 5 circles. Okay. Now they give me pi over 4. There's no pivot or anything, so that's here. We'll call this point B. Here's where B is. And then I say my reference angle for B is pi over 4. Okay, now I can think about what they're actually wanting here. They want these specifications, R less than 0, so a negative R, and then a positive angle. All right, so I look at this R thing kind of first. If it's a negative R, that means you're going to have to end up at the pivot location here. This is where you want to end up because that negative R would flip you and make you end up at B, the same exact location. So this negative R is going to have to be a negative 5 because there's 5 rings there. Now, in terms of what angle, remember, you want to end up at this location because as soon as you pivot, it's going to put you where you actually are supposed to be at point B. So where is this location? Well, that's when you look at this reference angle, pi over 4, and you think, where is pi over 4 in quadrant 3? Well, that would be at 5 pi over 4. So that's the angle I'm going to use. I hope that kind of made sense. If they want a negative r, you have to end up at the pivot point because the negative is going to pivot you back to where you're actually supposed to be. I hope that makes sense. Let's look at some more. Let's look at like number 37. One half negative pi over 4. So here's 1, radius 1, meaning 1/2's like there. All right, so I like to plot the original first. It's a negative angle, but a positive r. So there's no pivot or anything. It's just I rotate this way when I do it. So negative pi over 4 would put you like here. And the 1/2, I go halfway to that circle. All right, so this is the original. We'll call it A. And my reference angle for A is pi over 4. All right, now they're going to want these specifications. That's an r less than 0, so a negative r, and then an angle between negative 4 pi and negative 2 pi. Now this is kind of a weird scenario, so we're just going to call it negative theta for now. If they want negative r, that means I need to be aiming for the opposite location because the negative r will flip me back to this actual point A. So I need to be looking for this spot. And so my negative r needs to be negative 1/2. All right, so remember, I'm aiming for this spot right here. Now, in terms of where is that? Well, if it was a positive theta with this reference angle pi over 4 in quadrant 2, that would be at 3 pi over 4, right? Right here. But they want like an angle between negative 4 pi and negative 2 pi. So the way that you do this is you start subtracting full circle amounts, which is 2 pi. So you really need to be looking at it like this, minus 8 pi over 4. Negative 5 pi over 4 would be the first, like if I took one full loop away. And that makes sense because negative 5 pi over 4 would put you right where you wanted to be. And then the pivot would put you at A. I know it's getting complicated. So, but this doesn't fall within the criteria. They want between negative 4 pi and negative 2 pi. So you have to take another loop off. So negative 13 pi over 4. It still puts you at that same location, but now it's within the specifications that they want. So that would be my answer for that one. I hope that's not too confusing, but let's keep moving. Let's look at this bottom section real quick. Then we'll start converting. They want 4 different ways of representing this point. So the first thing you should do, let's look at like, well, you need to realize when they say 4 different ways, there's one with a positive r, positive theta. There's one with a negative r, positive theta. There's one with a positive r, negative theta. And then there's one with a negative r, negative theta. There's 4 different ways you could basically say you're at the same location. So let's look at the first one. I like to plot what they give me first. So 2 circles. And there is a pivot, but a positive angle rotation. So the positive angle rotation, but then the pivot, right? So here's where normal would be. but since there's the pivot of the -2, it puts you here. So the actual location of, we'll call this point A. Point A is right there, not on the red. All right. So this one that they gave me was a -r positive theta. They already gave us this one. So positive r positive theta is probably the easiest to get. If it's a positive r, it's just +2. Because there's only 2 circles there. And in terms of positive theta, you have to think, okay, what positive angle rotation would get me to point A where I wanted to be? That would be at 3 pi over 2. So that one's the easiest to get. And then this next one, -r positive theta, that's the one they gave us. So we already have that one. Now we have to get a positive r with a negative theta. So positive r, it would automatically be +2. But with a negative theta, so like what angle when I rotate this way would get me to the location I wanted to be at? Well, that would be -pi over 2. Because you're just rotating pi over 2 amount, but negatively. All right, and then the last one's probably the hardest, the -r negative theta. So basically you have to imagine this. The -r is going to mean that you're going to want the oppo of your final actual location, because that -r is going to pivot you 180 degrees and make you be where you actually wanted to be. So when they say -r, I'm aiming for the oppo location. And this -r would automatically be a -2. But now I need the negative theta, the negative angle rotation, to get to this oppo. Well, this amount right here would be -3 pi over 2. Okay, let me do one more of these because they are a little tricky. But the more you do of them, the better you're going to get at it. So let's do like 42. First of all, plot what they give you. 4 circles. Okay. -3 pi over 4 is your theta. So that's like there. So the original's here. We'll call it A. Here's where A is. Now I need to list 3 other ways to get to A. So the first one, let's list out what it's going to be again. You're going to have one with a positive r, positive theta. Then you're going to have one with a positive r, negative theta. Then you're going to have one with a negative r, positive theta. Then you're going to have one with a negative r, negative theta. Okay. They gave me, when they gave me A, they gave me a positive r and a negative theta. So I've already got that one done. Now, positive r, positive theta means if it's positive r, it's automatically that +4. And then if it's a positive r, not negative, I don't need to be thinking oppo or anything. I just need to give the positive angle rotation to get to that location. Well, since the reference was pi over 4, to get to this location, it would just be 5 pi over 4. Like that. Okay, now the next one, -r positive theta. If I see -r, I should do it in a different color. Let's do it in green. If I see -r, I instantly set up an oppo target location. Because this -r, both of them being -4, means I'm going to have to do a pivot from this location to end up exactly where I wanted to be. So now I just got to give the angles for this green location. So the positive angle would just be pi over 4. The negative angle would be this total amount, which would be negative 7 pi over 4. So that's kind of how you do these polar coordinates and graph them and represent them in different ways with different r's and thetas. All right, now let's look at actually converting these. This is where it's going to get a little tricky. Okay. Here we go. A couple things, background information you're probably going to want to know going into this. For section B, you need to know that x is r cosine theta and y is r sine theta. I'll wait for C as well. C has some important information you need to know, but I'll wait for that. Let's go ahead and look at all these. All right, look at number 11. And when you do these, you might even want to draw the first quadrant. So let me draw the first quadrant for you real quick. All right, so here you go. I would have this information on my paper. I'd have the first quadrant and all students take calculus. Because what's going to happen is you're going to need to identify the r and the theta for each of these. And then in order to make them like an xy coordinate, you go like this. You go r cosine theta, comma, r sine theta. So r was 3, so it'd be like 3 cosine theta was 7 pi over 4. And then the next one would be 3 sine 7 pi over 4. So you have 3 times cosine 7 pi over 4, puts it in quadrant 4, so cosine's positive. Reference angle is root 2 over 2, or pi over 4, which the cosine of that is root 2 over 2. So this one's 3 times root 2 over 2. Oops. Okay, comma, 3 times the sine of 7 pi over 4. Well, that's still in quadrant 4, which means sine is negative. And then looking at my reference angle, it's going to be negative root 2 over 2. Now you just multiply it out. So it'd be like 3 root 2 over 2, comma, negative 3 root 2 over 2. Just like that. And then one more thing I'll do is I'll kind of think to myself, okay, if the original was at 3 7 pi over 4, that's 1, 2, 3 loops with 7 pi over 4 rotation, puts it here. We'll call it A. Here's A. I'll check it against my new one. Just make sure I'm in the same quadrant. So like 3, if I graphed this, 3 root 2 out, 3 root 2 down would put it like here. Yep, that's where A is, quadrant 4. So I kind of know I'm good to go. That would show you if you missed like a negative, for example. Let's look at another. Look at like number 12. Okay. Your r is negative 4. And your theta is 2 pi over 3. So converting this, it would be r cosine theta, r sine theta, like this. All right, 2 pi over 3 is in quadrant 2, so sine's positive, but cosine is negative. So this one would be like negative 4 times cosine 2 pi over 3 is going to be negative 1/2. Then this other one, negative 4 times sine 2 pi over 3 is root 3 over 2. All right, so this first part becomes a 2. The second part, if you multiply this out and reduce it, you will get negative 2 root 3 over 1, or just negative 2 root 3. So this would be the rectangular coordinate once converted. Now the last thing I'll do is I'll check it against the original. So here's the original, 4 circles. 2 pi over 3, but with a negative r, so there's a pivot there. So 2 pi over 3 puts you here, but then there was the pivot, which would put you here. So I need to end up in quadrant 4. So now I look at what my rectangular coordinate is, this one, and I'd be like, okay, 1, 2, negative 2 root 3 would put me like here. Okay, it's in quadrant 4. It matches, so I didn't miss any negatives, which means as long as you got these x, y's right from these right here, you're good to go. All right, let's look at one more. And then I'll show you how to convert it the other way, which in my opinion is a little bit more difficult. But let's look at like number 19. This is a quadrantal, 2 comma 0. Your r is 2, your theta is 0 pi. So it'd be like r cosine theta, r sine theta. All right, so that's 2 times cosine of 0 is 1. 2 times sine of 0. I wrote thetas. I meant to write 0 pi's here, because that's my theta. But anyway, sine of 0 pi is 0. So this one would just be at 2 comma 0. So converting them that way is not that bad. Just follow this equation right here. Now let's look at the other way. In order to do the other way, the background information you need to know is that r is the root of x squared plus y squared, kind of like Pythagorean theorem. And your theta is the inverse tan of y over x. Now, this is the part that's probably going to mess you up, because most of y'all probably know how to run Pythagorean theorem. It's the tan that always gets you. So let's look at number 21. This is a rectangular coordinate. I know that because when I look at it, there's no theta. There's no angle that they're giving me. So like, if I were just to plot this normally, it would be like here in quadrant 3, right? All right, so let's go get the r first. Your r is the square root of the x squared plus the y squared. So I don't know if you know how to do like negative 2 root 3 squared, but it looks like this. All right, I shouldn't have to teach you that, but there you go. And then the negative 2 squared is 4. So you're really looking at the r of 12 plus 4 is 16. So the root of 16 is 4. So in terms of answering this question, your r is going to be 4. Now, you still need to find your theta, and this is the hard part. So basically, you do this. You run inverse tan of the y over the x, so negative 2 over negative 2 root 3. You're going to need to reduce this. So like the negative 2 over negative 2 will cancel, and this will just become 1 over root 3. Now, I also like to write y over x, because what's going to happen is I'm going to look up here at my reference angles, and I'm going to look for a y with a numerator of 1 and an x with a numerator of root 3. So that would be this right here, pi over 6. So you go and you say, okay, my reference angle is pi over 6. Now, if you noticed when I did this problem, I graphed the original first. I graphed this coordinate first. because it tells me I'm in quadrant 3. So why this is important is because now you just need to give where this reference angle is in quadrant 3. So in quadrant 3, this angle would be at 7 pi over 6. That's the angle you're going to use in your answer. So again, I graphed original first, which told me what quadrant I was in. That way, when I ran this inverse tan, I knew to get my reference and then just say where it is in quadrant 3. So let's look at another. I hope that made sense. I'm going to have to rewrite some of this. I accidentally just erased it. Okay, let's look at like number 23. 5, -5. Remember, I like to graph these first. 5, -5 is here. So I know I'm in quadrant 4. All right, let's go get the R first. It worked like this. Pythagorean theorem, basically. The x squared plus the y squared. So 5 squared plus -5 squared. So you'll get root 50, which is 5 root 2. So in terms of my answer, my R is 5 root 2. Now I have to go get theta. This is the hard part. So I go, okay, theta equals inverse tan of y over the x. So this is an inverse tan of -1 over 1. All right, so that means your y and your x have to be the same. So your reference is pi over 4. So I write, okay, reference is pi over 4. Now, I need to give the quadrant 4 answer for where pi over 4 is. So the quadrant 4, where that is, would be 7 pi over 4. This is going to be my theta. Nothing to it. Okay, let's look at a hard one, like number, I guess, 28, and then we'll do a quadrantal, and then I'm calling it because this video is already very, very long. All right, look at 28. This is a hard one in terms of finding your R and in terms of finding your theta. So let's do R first. -3 root 6 over 2 squared plus 3 root 2 over 2 squared. Okay, everything gets squared. So here's what it's going to look like. The -3 gets squared. The root 6 gets squared. It just becomes 6. And the 2 gets squared. The 3, I'm on this one now. The 3 gets squared. The root 2 gets squared. And the 2 gets squared. So it's really like root 54. Oh, not root yet. Sorry. It's really like 54 over 4 plus 18 over 4. Well, that's the square root of 72 over 4. And the square root of 72 over 4, I would divide that first. I would call this 18. Because once you know you're at root 18, well, that's just 3 root 2. So I was really just doing that to show you like how these things get squared out. The -3 gets squared. The root gets squared and drops away. And the denominator gets squared as well. All right, so that's how I'm getting my R of 3 root 2. Now I still need theta. And so I would have plotted this point, the original. -x, +y would put it here in quadrant 2. All right, so now I have to go get theta. It's going to look like this. Inverse tan of the y over the x. Now you're going to need to simplify this first. So what you have is you have 3 root 2 over 2 divided by, I like to put times and flip this bottom fraction. So it'd be 2 over 3 root 6, but it's negative. All right, cancel the 2's, cancel the 3's. You can divide root over root, so you can call this bottom one root 3 and root 1, like that up top. So when it's all said and done, you get negative 1 over root 3. This is your y over your x. So you're looking for a reference angle where your numerator on your y is a 1, and the numerator on your x is a root 3. That would be pi over 6. So this just basically tells you your reference is pi over 6. Then you need to be like, okay, well, I needed to be in quadrant 2 here. So in quadrant 2, that's 5 pi over 6. That was a rather difficult problem. Okay, last one. I'll do a quick quadrantal. They're easy as well, but let's go ahead and look at one. Let's look at like number, doesn't matter, number 30. Now let's do 29. All right, so the original point is here. Negative 3, 0. Your r is going to be the root of negative 3 squared plus 0 squared, which is the root of 9, which is 3. So your r stayed the same, or was just 3. Sorry, I shouldn't say the same. But you still need theta. Okay, now on the quadrantals, you kind of just got to use your head. Where is this? It's at pi. You don't, on a quadrantal, you don't need to go through that whole inverse tan y over x. Just use your head. Where is this angle? It's pi. Look at the next one, 0, 3. I can instantly tell you that since it's here on this quadrantal, my theta is going to be pi over 2. And then, so I just really need to go find the r, which would be 0 squared plus 3 squared under a root, which would be 3. So that's how you handle the quadrantals. Don't let them confuse you. They're super easy. Just tell me where this angle is, you know? All right, well, that is basically everything you need to know about plotting polar coordinates, graphing, converting, everything. So hopefully it wasn't too confusing, and I hope this video helped.